Welcome everyone. My project is efficient vertical forwarding traffic flow of software-defined network in telecom domain. I would like to thank my guide Mrs. Sharmila for guiding me since the inception of this project. Let's now get into my project. Abstract. The concept of software-defined networking has been successfully applied to data centers and campus networks, but it has had little impact in the fixed wireline and mobile telecom domain. We propose extending the concept of SDN so that it can tackle the challenges of the telecom domain. Existing system. Traditional telecommunication systems were used. Firmware has been loaded and packet flow in streamlined method. SDN has been successfully involved in data center and campus network. Tunneling solutions addressed the problem of performance issue and packet loss. Drawbacks. Traditional networking approaches are too complex, closed and proprietary. Network changes are difficult, slow and risky. The lack of network control and application interaction. New services required two new specialized skills. Proposed system. The Open Networking Foundation software-defined networking is transforming our outmoded WAN designs, decoupling the control and data planes, centralizing network intelligence, and abstracting applications from the underlying network infrastructure using the open flow standard. All the challenges of the service providers, which is storage, bandwidth, flexibility, mobility, and security, can be addressed by deploying SDN. Advantages: operational savings, flexibility, improved uptime, better management, planning, infrastructure savings. Literature survey. Title: Split Architecture Applying the SDN Network Concept to Carrier Network. The concepts of SDN, OpenFlow, and required modifications for carrier-grade abilities. A constraint of shared use of infrastructure is used to guarantee the total separation of access of influence of the control planes of different operators to each other. Title: Latest Trends in Telecommunication Standards, authored by Costa Perez. Core technology enhancements, consideration of raising disruptive technical concepts, expanding into emerging use cases aiming at an increase of future market size. This is the architecture diagram of my project. It consists of application layer, control layer, and infrastructure layer. This is the architecture of the proposed SDM system. Modules involved in my project: bandwidth on demand, bandwidth exchange, pay for quality of service, network features for pay. Bandwidth on demand. Bandwidth on demand services enable enterprises or cloud providers to dynamically establish or resize connectivity. Pay only for what they consume. OSS or BSS systems redesign their control applications for each vendor or to limit their services to a single vendor. Bandwidth exchange. For operators, it is to drive their buy, build versus lease decisions. Integration of network operators management systems into the bandwidth exchange BSS or OSS. Reduced operational costs from the automation of bandwidth acquisition and provisioning. Pay for quality of service. SDN provides tools that enable network operators to transform their network from an undifferentiated bit transport commodity to a value-based resource. The resulting unpredictability of device and server locations only exacerbates the traffic volume dilemma. Network features for P eliminates the management burden and expenses of the customer located routers, facilitates simplified integration into automated commissioning systems, enables a simple service upsell to managed firewall and managed security services on demand and without truck roll.